15. All right, we got two of them. Now remember what we have here. We have two different equations. These would be impossible to solve algebraically. You must use a graphing calculator, okay? And how we set this up is that this is going to be your y1, that guy. This guy over here will be your y2, okay? So let's go ahead and actually do that in the graphing calculator. Now we could graph transformations right here on this paper, but this is really, I want you to be able to be very proficient on the graphing calculator. So let's go ahead and just take a look here. Y1 will be in blue, Y2 will be in red, and so I will just type exactly as I see it. That's an absolute value, and absolute values are in the second window. You'll see the ABS. ABS will produce the bars. All right, and then we got x plus 3, so x is here, plus 3. We get outside, and then we do the minus 1. Now we can graph this just to see it, okay, and that's actually what we'll do. We'll do a zoom standard. So zoom standard will adjust my window to a 10 by 10 by negative 10 by negative 10. All right, oh, I have an inequality there, so let's get rid of that. Somebody's messing with my calculator. There. Try that again. What? No. No. Oh, I didn't hit OK. Okay, gotcha. Okay. All right. All right, so there it is. These calculators do inequalities. We're just not doing them right now. We'll do them tomorrow. This guy is the quadratic. So we're going to go here. He is just x plus 2. And then we're going to hit the caret button right here, which will make it go up to the superscript, and we'll write 2. Or you could have just hit the square button, which is right here. All right, so now this is definitely not an inequality. Let's go ahead and graph it. All right, so it looks like these guys intersect right around there. Now that looks like it could possibly be two intersections. So I'm going to go in, I'm going to zoom in, and I'm going to move my arrow there. Let's see if there's actually two. 1, 2. Okay. So here's where the graphing calculator really does its good work here. So it looks like I'm going to actually need the graphing calculator to tell me exactly where those are. I don't quite trust how it looks. So if you remember, we can do second calculate, the CAL, and that takes us to an intersection. We can actually get that intersection. I'm going to focus on the one to the left first. Okay, so it's right there. All right, and then the next one, we're going to go right to the other side of it, hit enter. And then it asks for a guess, and the guess we're going to put right in the middle. All right, and it looks like the intersection is -2, 0. Okay, so it did actually hit the crosshairs there. Okay, so I didn't trust my eyes. So now I'm going to go here, and that actually looks like -1, 1. But let me verify that. Second calc. Oops, nope. Sorry. Second calc. I hit alpha. I'm going to do intersection, but now I'm going to move over here. Okay, I'm going to go on the left side there. I will go on the right side of it here, and then I will go to the guess there, -1, 1. All right. Okay, so those are the two intersections here, and algebraically this would have been very difficult to solve. All right. All right, so where are we at? All right, next one is going to be a V shape, and we're going to move over to the left 2, and we're going to go down 3. So left 2, down 3. Now what I will do is I will look at this +2. That +2 tells me how steep my V is going to be. All right. Now because he is a +2, that means he will be going up with a slope of 2. All right. So slope of 2, and I'm going to that right there. Okay, now what it's asking me is what is greater than 0. So what we're doing is we're kind of drawing a line here. We're saying what are the pieces that are above 0? And it's this one, and it's this one. Everything else is below 0, so we do not want those. Now it does say or equal to, so we do want to include those portions that actually hit the x-axis. Now that's right there in the middle, and that's right there in the middle. Okay. So notice then that these will be decimals. This is going to go from negative infinity to negative 3.5. Okay, u. Okay, here it goes negative for a bit, and then it takes up at negative 1/2, and then it just shoots off to infinity. All right, so this is the solution. Because it's an inequality, it means we can have more than one answer. It's not going to just be equals. Okay. All right, where are we at? 6. Okay, let's go ahead and let's see if we can get these done here. All right, so here I'm going to actually rewrite this for a little bit more space. All right, so we got x plus 4y equals 15, and then 2x minus y equals negative 15. What you want to be careful for, well, you want to think, do I want to use substitution or elimination? You'll actually have one of each on the test. You can actually solve it any way you want, but I'm going to put one that's good for elimination and then one that's good for substitution. All right, so when I look at this right here, I can see that I've got a I can do whatever. I can get rid of the x first, or I can get rid of the y. The only reason why I'm choosing the y is because this guy already has a negative and he is already positive. So if I just multiplied this entire line by 4, then I can actually just get rid of the y's. So I'm going to go ahead and do that in the next step. And I'm going to rewrite the first line, okay, because he's not changing, but this one is. And so now when I multiply by 4, I'm going to get 8x. I will get negative 4y, which is what I want, and then 4y, or 4 times negative 15 is going to give us negative 60. Okay. All right, so the y's go away. I have 9x. Now what this allows me to do is it just allows me to just focus on one variable at a time, and then I will go find the next one. This is going to give us negative 45, and when I divide both sides by 9, okay, I will get x equals negative 5. All right, so that's 1/2 of my solution, not the whole of it. Now I can pick any one I want. I guess I'll just put it into this guy because he's just plain old x. But I'm going to go ahead and plug in the negative 5 for the x, and now I can figure out what y is by setting it again equal to 15. And here's just a two-step equation that I'm sure you've already done 1,000 of these in your life. Got to add 5 to both sides because remember we want to isolate y. So here's 4y. That's going to equal 20. Divide both sides by 4, and we have y equals 5. Okay, so put it together. These two lines, okay, if I graph them, all right, it is going to give me an intersection of negative 5, 5. We haven't really investigated the practical reason why these are great, but they're extremely useful in lots of applications that we will get into. Right now, we just want to focus on the skeleton structure of the algebraic engine. All right, last one. We're at the 8-minute mark. Okay, so let's go. You know what? I'm gonna have to make this its own video because if I go to 10 minutes, then it won't upload to YouTube. All right, gotta stop right here.